it's important to just talk a little bit about that. We find that most of the engineering colleges at the moment, we find that a lot of the training is theoretical and it bears little relevance to the kind of work that you do outside. So eYantra for the last decade has been trying to overcome that by giving practical exposure to students. Skills which are very relevant to them in finding jobs, in going for higher degrees, in doing startups, practical skills. Skills like building devices of various kinds, modeling them in various ways. And we train you in all these skills through our two flagship competitions. One is the eYantra Robotics competition, and the other is the eYantra Innovation Challenge, which is running right now. So EYRC and EYIC. EYIC's theme this year is building technology for uh, building inclusive cities, cities which are friendly for people with disabilities and things like that. And we are very, very excited about that right now. And typically, eYantra robotics competition trains you in skills. And by that, we mean things like what you'll be learning about this morning. SolidWorks, my colleague here, Saurabh, will take you through a short program where he'll kind of give you an overview of SolidWorks and solid modeling and stuff like that. Very important set of skills today because typically when we train you in things like control systems and various other perception, path planning, AI, everything, we do it inside a simulator where you're working with models. And Saurabh, for instance, is working on a very interesting theme, which is part of the competition this year, where you have to build a dairy bike robot, right? A model of that, which is doing various things inside a simulator. And eventually you have to actually build the robot and make it solve a problem. So these are all very practical skills. You'll find it very relevant. And nowadays people are saying metaverse and stuff like that. All these things are totally consistent with the kind of skills required there. So I'd like to welcome you on board. And without much ado, hand the floor over to Saurabh. Over to you, Saurabh.
Yeah, hello everyone. Am I audible? Am I audible?
Yes, you are.
Okay, yeah,
Yes.
yeah. So good morning everyone. So welcome to the session, technical session. And so today we'll be talking about SolidWorks as well as 3D printing. Okay. So yeah, let me share my screen first. Okay. I hope my presentation is visible.
Yes, we can see your presentation.
So a short introduction of me. So myself Saurabh Patil. So I'm a Mechie by graduation. I also have a master's degree in robotics from IIST Shibpur. And here at eYantra, I work on many interesting projects and especially hardware projects. Also, I have a good working background in control system area as well. And as sir has already told you, so I'm also a theme developer for the theme delivery bike for this year's EYRC competition. Yeah. So so as you can see the title over here, that is SolidWorks and 3D printing. So these are very common skills which are required for every domain when you are trying to design something. Okay. So and these are also interconnected. So SolidWorks is a basically a CAD modeling software. Many of you must already have used some kind of CAD software. So be it SolidWorks or Fusion 360, there are various other softwares as well. Okay. So these CAD softwares are used to make a 3D model. Then you process those 3D models, and for prototyping purpose, you can also 3D print those things. Okay. So we'll now one by one look at how these things work, and I hope everyone is over here. And yeah, So if you have any queries, you can put in the chat box. So at the end of the session, I'll be answering those. Okay. So in between also, I'll be asking some questions. So maybe, yeah. So I will looking at the chat response. I will interact with you. So I guess the host has muted everyone. So don't try to unmute, because if we give the unmute option, then there will be a lot of noise. Okay. Yeah. Okay. Let's now begin. So just a short introduction. So before that, I would like to uh, tell you a short anecdote. So there's a person, he's a MIT graduate. Okay. So during 1970s and 80s, uh, what he did was he was very good at mathematics. Okay. So there's a team called Blackjack team, MIT Blackjack team, right? So many of you must have heard of casinos and all. So Blackjack is a game played in casinos. Okay. So why am I talking about casinos when I start talking when it's a top when the topic is of SolidWorks? Okay, you might be surprised. The thing is, this person, he used his mathematical skills to trick the blackjack teams that are there in casinos, and he won many millions of dollars. Okay, so we will get to know why I'm telling you this anecdote. So what this person did was he monitored how many cards are being used, and by tracking the cards and using some probability, as you know, whatever games are there in casinos, they are based on probability. So mastering that, what they did was they tricked the system and earned many millions of dollars. So now once he got millions of dollars, so what would you do if you have millions of dollars? So you can just put the response in chat as well. Let's say you have great mathematical skills and you have millions of dollars. Can you put in chat what you will be doing? Yeah, I need some responses in the chat. I hope everyone has access to the chat box in WebEx. Okay, start a casino. Okay. No, annotation is not allowed. Okay. Invest in stock and share market. Okay. Many people are requesting annotation. Do not click the annotation. You can just find the chat bar over there. You will see chat with participants. There you can type. Okay, develop the best gaming and working setup in the world. Okay. Okay, invent something which needs mathematics. Okay. Okay. Invest in something which, okay. Any more responses? So I will repeat the question again. Let's say if you have almost millions of dollars, and you're also good at mathematics, what you would do? I guess we have got pretty nice responses. Someone wants to start a casino, someone wants to invest in stock. Okay. So yeah, so let's see. So here you can see a person. So he was member of the MIT Blackjack team, and he literally earned millions of dollars using mathematical skills. Okay. So his name is John Herstick. So now why am I introducing him to you, the person who earned millions of dollars in blackjack, right? So the reason is he is also the founder of SolidWorks. Okay. So what he did when he had millions of dollars and he was good at mathematics, he made a mathematical tool to make 3D designs, right? So that's how SolidWorks was founded, and this is in year 1993. Mm. So he later, I guess in 1997 or something, he sold the SolidWorks to Dassault Systems. So Dassault Systems is the current owner of SolidWorks. So, and even after selling it to Dassault Systems, he was CEO till 2011 or something. So that was just a small story about how SolidWorks was invented. So you have a couple of $1 million, you can do such amazing things. Yeah. Okay. So let's now get to the technical part. Okay. So yeah, many of you might already have SolidWorks installed. So this session, as it is a technical session, I will only be showing you like what things you can do in SolidWorks. So I will not wait for you guys to do something practically. Maybe in the background you can work on SolidWorks, but it is recommended that you just follow the instruction right now. Maybe afterwards, on as this video is also available on YouTube, you can follow the same instructions and make your own SolidWorks models as well. So I won't be showing you how to do installation, as in the 1 hour session, the whole time will be taken only by installation part. Okay? So this is it. The installation of SolidWorks is simple. Like you have the exe file. Uh, you normally how you install a software in Windows, the same way you have to install, and at the end it will ask for a license key, and you will have to provide the license key. So there are many colleges which buy the licenses for you. So, and also there's a personal use license as well. So it is recommended to use licensed product only. Okay. Okay. So I hope installation part will be sorted out by the candidates by themselves, because we can't go on showing that in this video. So yeah, let's start with the basics. Okay. So you can see a geometry over here. On the left hand side, you see a 3D representation. Also, it is called as isometric view. So I'm just introducing these terms so that once we start working with SolidWorks, you are already familiar with them. So to make a 3D object, basically it is combination of multiple 2D objects, right? So on, you can see the 3D representation in left, and if you just try to imagine that you are looking at the 3D representation in top view, so you will get this. I hope my pointer is visible. Yes, Gargi, can you confirm if my mouse pointer is visible? Okay,
Yes, we can see it.
okay, yeah. So this is how this 3D figure will look in top view, right? So let's say now we look in from the front side. From the front side, if you look at this 3D figure, it will look something like this. And same way in the right side. But you can see some differentiation. On the right side, you have a dashed line. Yeah, sorry, there was some disruption. Okay. Yeah, on the right hand side, you can see the right side view of the same 3D model. So here you can see there's a dashed line. Okay. The reason uh, somehow my okay. So the dashed line you can see over here is because this is on the inner side. So whatever feature you can't see in the from the right hand side, whatever you can't see directly, those are represented always by a dashed line, as you can see over here. But the features that you can see from the same side directly, those are always mentioned in the solid line. So you can see this. I will just map this right hand side view in the 3D representation. So this line over here is the same as this, and whereas the top line, you can see the top C portion, that comes from this orientation. Okay. Whereas the hatched line inside, you see, that is this one. So this is a basic thing about how to represent a 3D object in orthographic projection. Okay. Yeah. So let's move on. So yeah, now that we have got idea of representing 3D and 2D objects, let's now look into what SolidWorks, how the SolidWorks GUI looks. So here you can see, so once you install SolidWorks and open the SolidWorks, you will see this main GUI over there. So on the top is the menu toolbar. So from this menu toolbar, you can access many things. So you can start a new part file, new assembly, or a drawing file as well. Once we jump to actual working on SolidWorks, you will see all these things in detail. Okay. So right now I'm just introducing these things. Yeah. So this is the GUI. And on the here you can see you can enter some search commands. So in case you are not able to visually find out some command, you can search those commands here as well. And on right hand side you see the task pane. So this task pane we will be also using it practically. Yeah. So once you are in the GUI, you start a new file, you will get this prompt on your screen, right? So here you can see there are three things: part, assembly, and drawing. Yeah. So let me just briefly explain to you what these things are. So when you're doing 3D modeling, so first what you do is you create some sketches and you extrude them, or you give them the third dimension, right? So that thing is done in the part file. So in part file, what you will do is initially you will create a sketch, then you will extrude it in the third dimension and you will get a solid body. Yeah. So once we are done with the part file, what we'll do is, let's say we have made 4 or 5 parts, then we'll jump to the assembly file. In assembly file, what you do is you join components and add mates to them. Right? So here what you'll do is you will take multiple components and let's say one component should be parallel to another, then you add that as a mate. So that's how an assembly is made. Or let's say you have a nut bolt assembly. So you have threading inside. So you made them as nut bolt pair and they will be assembled. So then the third stage is the drawing. Third stage is the drawing. So where after doing 3D things, what we do is you create a drawing. The reason for that is, let's say you have made a 3D model and you are supposed to manufacture it, or you're supposed to outsource the manufacturing part to some different place. So these manufacturers, they don't understand 3D parts, right? So we convert those 3D assemblies into a drawing, and this drawing has details of everything, like what dimension each side is. If there's hole in the drawing, then what diameter of that hole, what is the diameter of that hole? Also, what should be the tolerance? And there are various factors that you do in drawing as well. So these drawing things also depend on what material you're using. So let's say you are making a plastic thing, or if you are using some metal, let's say stainless steel alloy or some other metal. So depending on that, you adjust those parameters, and these parameters you learn through experience. So what should be the tolerance, and what different dimensions you can give, like that. So these are the three core components of a CAD model: part, assembly, and drawing. So you go like from left to right. First you create multiple parts, then assemble it, then create a 2D drawing for the manufacturer. Okay. Yeah. So as we go inside the part model, so here we are at the part model, we go inside it, you will see this is the main GUI of part model. So here also you can see different thing. So this menu toolbar is same from the home GUI. Now you can see an additional toolbar over here. So this is a command manager. So from here you can do different things like extruding or revolving the geometry that you have. Then this area over here you see where you can see different planes. So this is the front plane, then you see a perpendicular top plane, then there's the third right plane as well. So this is the graphics area. This is where you will be doing your designs, or you will see the visualization of the designs that you are drawing. Okay. So on the right hand side, you see some icons, the home icon or the folder icon. So this is the task pane. So here you can access some standard toolboxes as well. Then also you can change the appearance of the solid body that you have. So you can do various things from the task pane. So on the left hand side, what you see is a feature manager tree. Okay. So this feature manager tree shows the detailation of the thing that you are doing. So as you can see, this yellow symbol is the part symbol that we have already seen. Yeah, I'll just turn the marker. Yeah. So you can see different things over here. So material, you can assign certain material to it. Then you will see the planes that you can see in the graphics area. Those are also shown over here: front plane, top plane, right plane, as well as the origin. So as we start drawing something, so you will see that there will be more components which will get added here. So if you first you start with sketch, so a sketch will come over here. Then if you extrude the sketch, then you will see another extruded part as well. Okay. So this was basic introduction to the GUI that is there. So let's now jump to SolidWorks, right? Just give me a second. I'll jump to SolidWorks. Yeah, I hope my SolidWorks screen is visible. Okay, yeah. So you can see the SolidWorks GUI over here, right? So I have increased the resolution of the SolidWorks. So if you open SolidWorks at your end, you might see some smaller icons. The reason to increase resolution is so that as I'm presenting this in a meet, so it should be visible to everyone, even if you are watching on a mobile phone, right? Yeah. So we have now already got familiar with the GUI. So this is now SolidWorks in action. So as I've shown, this is the menu toolbar. You can see different things. So in file, you see new and open. So if you want to start, you will click new. And if you want to open an existing part, you go through this. Then you can uh, toggle with some views that you have. Then here you have different tools that are there in SolidWorks. Okay. So these are different tools. Then in the same menu toolbar as well, you can see different icons. The home icon. Then again, you have shortcuts for the same things in file, the new and file. So you also have shortcut for saving the file, right? So this is the menu toolbar. So let's now start with a part. So once we click on new, yeah, so we are already now familiar with this thing. You can see the structure, the part, assembly, and drawing, right? So if you're a beginner, it is recommended to use this pane. If you're already have advanced experience with SolidWorks, then you can go to the advanced mode, and you can also have your own custom this start windows or templates, you can say, right? So you can first just look at my mouse actions. First, click on the part file and press OK. Or else what you can do is you can double click on the part as well. So now what we see over here is a GUI of the inside the part file, right? So yeah, so we have already got got to know basics of the thing. So this is the command manager. Then you can see the feature manager tree over here, right? So here you can see the task pane, and this is also top toolbar, right? So I'll show different features from here itself. So let's say you are in part assembly. Inside the command manager, you have different things. So you can see features over here. So you can do extrude, then you see sketch mode, then you see markup mode. Yeah. So this sketch mode is used for drawing sketches. We'll shortly do those things practically as well. Then here in markup, markup can be used for annotations. So you can like let's say you have a Sharpie in your hand and you make some want to make some markings in the 3D object. So let's say this is the front view or this or any detailation you want to mention, you can use the markup tool. Once in the evaluate, we can see different things. So you can do design study, then you can say interference detection. So interference detection is, let's say you create multiple 3D bodies and you are doing an assembly. So what you do is in assembly, you always check if there's an interference. As you see in SolidWorks, if you create two solid bodies, they can easily pass through each other. But that's not possible in real life, right? So for that, we always have to do interference detection. So while doing assembly, this can be used in many ways. On right hand side, also we can see the measure toolbar. So this measure is like a measuring tape that we have at our home. So you can use this tool to measure lengths or say angles or different lengths between two planes or two objects. So we can do various things with the measure toolbar. Right? So then we have different things. So you can see mass properties. So once we create a 3D body, this portion will also get activated. So with this, we can look at like whatever 3D model we have created, you can see the mass properties of it. You can also find what's the moment of inertia. Then uh, and other various things also we can add like the sensor performance evaluation. We'll not go into details of this as I'm just introducing the different panes that we have over here. Then there is another thing called SolidWorks add-in. Okay. Yeah. So SolidWorks is a pretty big software. So other than just CAD modeling, you can do various other things as well. So you can do circuit works. So you can make an electrical circuit inside. So these are add-ins of SolidWorks. Then you have 360 view add-in. Then you can, if you have a 3D scanner with you, you can convert that into a solid object. Then if you look at SolidWorks motion, so here if you create an assembly, you can create a motion file as well. So that way you can create small animations of mechanisms that you have made. So then you have SolidWorks routing. So this routing uh, can be used by like various different engineers as well. Then in SolidWorks simulation, you will see you can do stress analysis. These are basic features only. So if you want to do a detailed analysis of whatever CAD design you have made, you can use softwares like ANSYS, and there are various different FEA softwares, FEA, FEM softwares as well, right? So then you have SolidWorks toolbox as well. Yeah. These are added. So let's now begin with drawing some things. Yeah. So we are in the feature window. So I'll show the planes what we have. You see, this is the front plane, and you see this is the top plane, and you see this is the right plane. Okay. And as you can see, this marks the origin as well. So what you can do is, if you are too much new to SolidWorks, you can always keep this in show mode. That way you can access all the planes are visible to you. Okay. But if you have got used to these things, you can hide those planes as well. Yeah. So let's start with some basics. So let's say I want to draw something in the top view. Let's start with drawing a cylinder. Okay. So in top view, first you select the top portion, then you will see a sketch mode over here. Select that. So now once we are in this sketch mode, you can see a different toolbar is over here in the command manager. Right? So you will see various things over here. So first thing you can see is the line command. Then over here you see the circle command. Then you can draw a spline like that. You have rectangle command. Then center point R. Then you can draw an ellipse. Also you have a straight slot. Then polygon, and you can also add a sketch fillet. So there are various things. We'll look at them one by one. So let's say we want to draw a cylinder. So can anyone tell me if you want to draw a cylinder, in what sketch should I start with first? Just put that in the chat. Let's say I want to draw a cylinder. What sketch I will be starting with? Okay. The chat, I guess I see some people are still busy with the millions and billions story. Okay. Yeah, circle. Yeah. So what you do is you first select this circle command. Then you come to the center. This is the center point. I hope the screen is visible. then you select the center, then you drag and draw a circle of whatever dimension you want. So this is now a circle with some random dimension. So what you can do is close the dialog box. Now let's give some sort of dimension to this. So here you see a button called Smart Dimension. So click on the Smart Dimension button. You see, now you can give certain dimension to the circle. So the random dimension right now was 90 point something. So let's now make it 100 mm. Right. So we have now drawn a circle of 100 mm. So you can move this dimension, uh, the dimension where what it is showing, you can move it anywhere you want according to your convenience. So now that we have drawn a circle, so what we do is we exit from the sketch. So we are out of the sketch. Now what we'll do is we'll make this circle into a 3D object. So let first make sure that the sketch is selected. Okay. Then you press extrude. Okay. So now you can see as the sketch was in 2D, with extrude we can give certain height to that circle and the circle will become a cylinder. So let's see what different things we can do. So there are multiple options. First is blind. In blind, what we can do, we will give certain dimension, let's say 50, and that that much will be, so the cylinder will have height of 50 mm. So let's say we want to edit this again. So just right click on the boss extrude part, say edit feature. Yeah, so you can put in whatever height you want, or there is another option as well. So you can just drag this arrow and get whatever height you want. Let's say, let's make it 100. Okay. So this is now 100 mm. There are various other options to do extrusion as well. So first, as you saw, was blind. In blind, what you do is you enter whatever specific height you want. Okay. Then up to vertex. Let's say you have another body over this body. Then you can draw. You can extrude this 2D diagram to up to that vertex. Also, you can do extrusion to the surface. So there are various modes of doing this same extrusion, right? So this you will be using if you go into, like, if you are a pro user of SolidWorks, you will know these things already. Mm. So another thing you can do is, now we have this extruded part in one direction. Let's say you want to extrude with some another length in different direction. So for that, what you can do is tick on the direction 2. So now you will see from the same circle, from the same 2D geometry, there's an extruded part at the lower end as well. Yeah. So let's say we want to have some different dimension over here, say 20 mm. So we see that in the upper side we have 100 mm, on the lower side we have 20 mm. So our total height will be 120. So let's now verify if the height is 120. For that, what we do is we go to the evaluate mode, we click measure. Let's say we select this circle and we'll select this circle over here. So you see the normal distance mentioned over here is 120 mm. So now we have a cylinder of 120 mm. Okay. So this was basics of drawing and doing extrusion. So let's now look at various other things as well. So that is devolve, base, swept, loft, or extrude cut. So I'll show you how an extrude cut works. So now that you have your first 3D solid body, what you can do is, let's say you want a hole inside this cylinder of certain diameter. So you will select this top plane. So once you select, you will see various options over here. So in that, what you can do is you can draw sketch. So before we do the sketch part, we'll first go normal to it so that it's in front view, right? Now in this view, we'll draw a sketch. So let's say here we draw a circle of certain diameter, and let's say we'll give dimension to this circle. Let this dimension be 30 mm diameter. Okay. So let's exit from here, and then we'll do a extrude cut. So make sure that before selecting a feature over here, the sketch is selected. So the sketch is selected, then we'll do extrude cut. Right. So yeah. So now here you will see different features. As we know, this cylinder has 120 mm height. So you see, if you while doing the extrude cut, if you give a dimension of 50 mm, it will go to certain height only. Let's say instead of blind, we select through all. So through all is whatever 3D geometry is there below this. So this hole will be created through everything whatever is there below this plane. Okay. So that is through all. Then you can also use up to surface. So let's say you have another 3D body below this cylinder. What up to this surface will do? It will only create the hole up to this surface, the first surface that it sees. Okay. So there are various options that you can toggle with inside the extrude cut. So let's do blind of certain height only, 120 left. Yeah. So what we can see here, we have a cylinder and we have also done an extrude cut of 120 mm inside the cylinder. Yeah. So if you make increase the diameter of this, you can also get a like bigger cavity inside the cylinder. Yeah. So this was extrude and extrude cut. So let's now look at dimensions. Okay. So let's do the measuring again. So this is like a measuring tape. So you can see it will show various parameters. If you select this surface area, it will give you the area and perimeter as well. Or else if you select a edge only, then it will show what diameter it is. Also, it will show what is the center of this circle that you have selected. So this diameter is 100 mm, and if you select the inner circle, then it is 30 mm. Yeah. Okay. So this is some basics of extrusion and cut extrude. So let's now close this part. I will show you for saving this part. So here in the menu toolbar, you can see a save button. So if you click on save button, yeah. So you will see there's a format here. What you see is SLDPRT. So SolidWorks by default, a part file, it will be saving in SLDPRT format. So the name, whatever you want, you can rename it. So you can say this is a test file and test1, and you save it as SLDPRT. So you can see various options to save as well. So the default format is SLDPRT. Then there are various other formats in which you can save the 3D files. The 3MF format is there. Then you see you can convert this into a drawing file. You can save as an image as well. You can save as an STL file. We'll be looking into STL files once we jump to the 3D printing part as well. Okay. So there are various other formats, IGES, then you can convert it into step file as well. Step file is mostly used for interportability. So let's say you have a SolidWorks file, you want to open this in some other 3D designing software, then SLDPRT won't be supported in that software. For that, what you do is you save it as step file and that can be accessed in other softwares as well. Okay. So for now, we'll save this as SLDPRT. Okay. So I see a lot of chatter in the chat box. Let me. Somewhere else, no? Yeah. Okay. So there's nothing serious going on in chat. Okay. Yeah. So this we have now saved this file. So I'll just close this and create a new file. Part. Okay. Yeah. So let's now create something else. So let's jump to the front plane. In front plane, I will draw another sketch. So here we see the front plane. So these are the sketch options that we have. So once if you see the line command, there's a drop down menu to this as well. So in the drop down, we have line. We also can draw a center line as well as a midpoint line. So let's say we have a center line. So first what we'll do is we'll draw a center line along the y-axis that we have over here. Okay. So one thing you should know, simple line that you draw, this will be considered as a sketch component. But if you draw a center line from this drop down menu, this center line is always used for referencing, so that you can reference this dimension else. So you can, so this won't affect your 3D solid object. Okay. So let's now draw something in the front plane. Let's say, okay, I'll draw certain geometry. So yeah, so what you can see is I have drawn this thing continuously. So how you do is, so I'll just delete this thing and I'll show the part again. So once you are using certain command, this, after using that command, this command will still be accessible to you on this same click. Okay, so you start from here, you draw a line, you click over here, still the line command is activated, right? So you continuously you go on drawing whatever you want with the line command that is activated. Yeah, so here you can see we have drawn certain just a random geometry. Let's give some dimensions to it. Say 60 mm. Then we have over here some 120 mm. Okay. So always when you're drawing something in the sketch, you should look at this, what you can see in the bottom as well. You can see that this, it is showing that this sketch is underdefined, right? So you should make sure that this underdefined turns into fully defined before you go and extrude this part, or you whatever feature you use in future. Okay. So let's make sure that this is fully defined. So we can see. Yeah. So now we see that the whole sketch is turned black, and you can see over here that the sketch is fully defined. So once it is fully defined, that means you have given dimension to each and every component inside the sketch, right? So let's now exit from the sketch. Okay. Now we have a sketch over here. So let's now use another feature from here. So what we'll do is we'll use the revolve boss feature. Now see what warning it is giving. So what it is saying, if you want to use a revolve boss feature, the sketch should not be open. So can anyone tell me what part is open over here? The sketch is currently open, and non-thin revolution feature requires a closed sketch. Okay. So what you can see over here, just let me show. So what it is saying is this sketch is open at this end, as we have used a dotted line over here. Yeah, so that's why it is giving that warning. So let's now select revolve boss. You see, now we will use uh, this revolve boss command to create another 3D body. Okay. So you can select how much angle that you want. So let's say now because we are creating a cylindrical body, so the angle will obviously be 360-degree. Let's say we first draw 90-degree, then you can see it will only create a sector out of it. So this is a 3D body with a 90-degree sector, right? So let's say, let's now make it convert into a fully 3D body. So let's make it 360. That way, this will become a cylindrical body. Okay. Yeah. So this was revolve boss feature. So let's now uh, give some use some another command, that is the fillet. So what you can see, so this you have two cylinders over here, one bigger cylinder, and on top there's a smaller cylinder. So you can add fillet to this. So fillets are added so that there are no sharp corners in the manufactured product. So now I select the edge. So I have selected the edge of the cylinder, then I press fillet. So this fillet is in the command manager toolbox. So inside fillet, you can choose different parameters. So you see the edge that we have selected here, it is showing that. Then you can now here you toggle the radius of the fillet what you want. So let's say now I want 5 mm as radius. Now I click the OK icon. You see it has now added a fillet to the cylinder. So let's now increase. So let's say I have to increase the fillet. So just right click on the fillet, do edit feature. Okay. So instead of 5 mm, what to do is let's say we'll do 10 mm of fillet. Okay. So let's now click OK again. Yeah. So here you can see fillet command. So now let me add another fillet to the top cylinder as well. So here I have selected. I will add a fillet. So here we'll add fillet of 5 mm only. Yeah. Okay. So these are some of the basic commands that we have seen in the feature window inside the part file. So I will just go through different other commands that you can use. I will not be showing every command present over here, but I'll give you a review out of it, of everything. So as we had seen the revolve boss command, same way we have a revolve cut as well. That way in boss, what we did was we used a sketch and we created a 3D body. Whereas in revolve cut, what to do is you will use a sketch and you will cut the body in with certain angle or certain sector in like that. Okay, that is revolve cut. Then in linear pattern, what you can do is let's say you want to do something which is repetitive. Okay, so if I have created a single hole and I want this hole to be equally spaced on the 3D body and up to the end point, right? So what you do is you draw first a single hole, then you use linear pattern, then you mention what spacing you want, and that way let's say 5 or 10 holes you want to create, that many holes will be created, or whatever geometry you want to replicate. You don't go on drawing different geometry again and again. Okay, so what you do is you use a linear pattern. Same way you also have circular pattern. So as I guess the name itself says, in linear pattern we will have replicas in linear fashion, whereas in circular pattern you will do this along a circular area. Same way we have a mirror command. Let's say you draw a sketch, complicated sketch or like that, and the opposite side is a replica of that left hand side sketch. Then what you do is you just use the mirror command over there. Okay. Yeah. So these are some basic things. Then you can use these commands as well, the draft command or shell command. So once you start using SolidWorks on your own, you will get to know these features. Yeah. So that was basic introduction of how to draw parts. So let's now save this file. Okay. So for save, you can either go to this menu and select save, or you can also use shortcut keys on the keyboard. Okay. So will play, if I press Control S, then it will, the save menu will pop up. So you can name it now. The first command we had was test2. Test1 we had. Now we'll name it as test2. So save this. Now this will be saved as SLDPRT file. Yeah. Okay, let me now just go through the chat, see if there are any questions. Okay. Yeah, so the chat option that we have given is for you to ask questions. So this is not some Facebook or Instagram chat room. So please maintain the decorum of the session. Okay. Only ask technical queries in the chat. Also use the English should be used in the chat box. Yeah. So this was basic introduction of part files. So let's now look at, so as we have seen, we use certain sketch commands as well as features. So there are various shortcuts also that you can use. So instead of always moving the mouse from here to this sketch toolbar, what you can do is the most common things that you have, you can just pin it to the mouse as mouse action. So let's look at the what shortcuts we can put in. Okay, so we'll go here, we'll right click, then what we do is we'll customize. So inside customize, what you can do, mouse gestures. So you can see there are various mouse gestures for different modes that we have. So 2D sketch that we first started with, then here you can see the part file, then assembly and drawing. So these shortcuts are beneficial when you are doing some complex part, and so that you can easily access the commonly used things. Okay, so in Sketch you can see the line command, which is highly used. So I've added this as my mouse shortcut. On the right hand side I have escape and also have the smart dimension command over here. Okay, so I will just show you how to use the shortcut commands. So let me go inside a sketch that we have drawn. So I will just press the drop down button in the sketch. I will press right click and edit sketch. So we have we have drawn this sketch. So what we can do is right click the let's say the mouse that you have in the hand, you press the right click button and you just move left. So you see the line command was selected automatically. So I'll do this again, action again, and from here mouse command, if I go on the right hand side, it will press the escape button, and if you go on the top, it will catch the smart dimension mode. So these are the shortcuts that you can use. Okay. So yeah, so this was brief review of shortcuts. So let me just jump to the presentation that I have. Okay. I hope my presentation is visible. So we briefly got overview of how part file works. So here I will again see the sketch mode that you have seen over here. So we have now looked into all the features that are there. So different commands that we have. We also have trim commands. So with these trim commands, you can cut the line up to certain length, up to you can cut the line between certain parts. So that way you'll use the trim command. So we also saw the toolbar inside part mode. Okay, so this is the same toolbar. Yeah. So this is overview of extrusion process that we have. And so we extruded the 2D drawing and made it into 3D. So these are some shortcuts that we see. So ways to access the shortcuts. So with the mouse gesture, that is the right click of the mouse, you can access various shortcuts. So you also have a sketch shortcut toolbar. So that you can access with the S button on your keyboard. Then you have search command window as well. As we had seen initially, on the top side of the SolidWorks GUI, you'll see search command. So any command that you are used to, you can just click on the search command and you can type as line, and that command will be automatically selected. So once you start using SolidWorks, you will get used to these things. So yeah, so I will show now another mode of SolidWorks that we're seeing. Okay. So we saw how to make a part file. So now let's see how to make a assembly. So we had saved this part file. Let's now close this part file. Just make sure that it's saved. So we click on new command. So here we can first we have now looked into the part command, then we have assembly, then we have drawing. Okay. So in assembly, what we do is we take multiple parts and add mates to them. So I'll click on assembly, and inside assembly, you can see a same layout that we have. So here now it is asking me for files that I can use multiple. So we had created first, that is test file, test1 and test2. Okay. So I will select both of these files by pressing Control button and I will press open. So it will take a bit of a time. So here we have the first model that we had created. Then I will also place the second model. Okay. So now both both the different parts that we had created, we have them in single assembly file. Yeah, there are many people who are requesting annotation access. So please don't press that button. Okay. So this annotation is only for the users. Yeah. So I will just hold on for 2 minutes. Okay. So there's some issue in the lab we have. So I'll just change my internet connection and I will be back in a minute. Yeah, can everyone hear me? Gary, can you confirm? Am I audible? Hello? Yeah, am I audible to you? Okay, okay. I see people. Yeah, okay. Yeah, thanks. Yeah, so we had some brief interruption because of internal connectivity. So yeah, let's now begin again. So here we can see we are inside assembly mode and we have the two parts that we had created. Okay. So what you can say is the first part that we added, so it has added an F in front of it. That means the assembly feature has already fixed this part. So if you right click on this and if you click float, yeah, so you can see now both the objects are free. So you can select these objects and move along, move here and there as well. So let's say, yeah. So now both the objects are floating. So let's now do some assembly things. So first what we do is you add mates to this. So here you can see this, both of them are cylindrical objects. What you do is you click on mate command. Yeah. So you will see inside the mate command you have different things, that is coincident, parallel, perpendicular, tangent, concentric. So let's say we want to we select the outer body of this cylinder, then outer body of this cylinder, then you'll see it has automatically detected that these are cylindrical bodies and you can add concentricity to this. So you see now as we have both the bodies are floating, it is creating disruption. So what I'll do is I'll fix one body and right click on this and click fix. Okay, so I'll do the mating part again and click mate. So yeah, just hold on. Yeah, let me select the outer surface of this cylinder. Then out you will see it is showing the selection, that is face 1, then outer surface of this, and now it has detected concentric mate. So now you see that both of them are concentric, but I can still move them relative to each other because they are not fixed totally. So because we have only added one mate, that is concentric mate. So what we do now is let's say if we fix that this surface, the top surface of this cylinder and the bottom surface of this cylinder, what you will get is you will get a fixed assembly. So let's do that. Inside a mate, I've selected mate, then I will select top surface of this cylinder, then I will select bottom surface of this cylinder, and yeah, you can see it has already detected that they need to be coincident. So you can choose whatever command you want. Let's say you want it to be parallel, perpendicular, okay, or if you want them to be at certain distance, then you can also select this, and let's say 50 mm, then you can press 50 mm or certain angle you want. So for now what we want is we want to make them coincident. So as we can see over here, we have uh, two cylinders, both are concentric, also they are coincident. Now if I try to move this cylinder, it will definitely rotate, but what you can see, it is now not moving up and down because we have added a mate to it, right? So that's how an assembly is made. So this was just a short example of what we have created. So once you, let's say you are making a pulley and belt system or any other mechanical design that you are making, let's say a gear system, you have multiple gears over there. So therein this mates, you can add different types of mates and you create a fully functional assembly out of it. So with this assembly, what you can do is you can visualize the whole mechanism that you have. Okay. Yeah. So this was uh, brief introduction of assembly feature. So let's now save this file. For that, we click save. So it is giving an error, that is, do you want to rebuild or save the document without rebuilding? So what you always select is rebuild and save the document. Yeah. So here you see there's different format compared to the part file. In part file, we had SLD PRT file format. For assembly, what we have is SLD ASM file format. Okay. So here we'll keep the name as same, assembly 1 SLD ASM file, and we'll press the save button. So this was assembly feature in SolidWorks. So let's now, so as we had seen, there were three things in SolidWorks: part, assembly, and drawing. So briefly look into how to make a drawing out of a 3D object. So I'll close the assembly file that we have, and I will open a 3D test file that we had made. Okay. So we are back again in the part file that we had. So let's now make drawing out of it. For drawing, what you do is you go to new, click the drop down arrow and press on make drawing from part assembly. Okay. So you can see now we are jumping from the part assembly mode to the drawing sheet that we have. So I had already introduced how drawings are used. So basically, after creating 3D parts, you again convert these 3D parts into a 2D form so that the manufacturer who will be manufacturing these parts understands every detail of those things. Okay? So you can just print the sheet or you can send the sheet digitally to the manufacturer. They will print it and use those same dimensions to manufacture. So yeah, so once we are inside the drawing mode, you can see over here, we have the view palette. Inside view palette, you can see different views that we have: the top view, front view, right view. As you can see, it is a cylindrical body. The front view and the right view is symmetrical only. So let's first start with isometric view. I'll click isometric view. Whatever view you want, you click it and drag it onto the sheet that you have. So here you can see it is on the sheet. So I guess the sheet is small. So if you want to change the size of the sheet, what you do is you right click on the sheet, then go to properties, and let's have a bigger sheet, 11 A3 size sheet. Okay. So yeah, now see the size is sufficient. So you see this is the isometric view. Let's now bring in some other views as well. So let me drag top view over here. So once I drag top view, along with that, you can automatically get different views with the same click as well. Yeah? So here you see another view. Just by dragging the mouse, you will get different views. As this is cylindrical body, most of the views will be different views will be same only. So you can see another view. This is the diametric view. So here is the right hand side view. Yeah. So these are certain features of the drawing file. Okay. We'll increase the size a bit that you get clear idea. So you can drag these files and place it wherever you want. Okay. So once you have whatever views you want, so what you can do is you can give annotations to it. So the same way we had smart dimension in part file, we also have smart dimension here in drawing. So if I click smart dimension, I will give dimensions to the cylindrical area. Okay, you see there is certain dimension coming up. Then you click OK. Then let's say we want to mark this diameter. Okay. So there's the diameter that we have. Then let's mark this diameter. So you can also change the you can mention the dimension, what dimensions are present in the sheet itself. You can have all the dimensions in mm. So whenever you give certain things for manufacturer to the manufacturer, it is recommended that use all the dimensions should be in format only. Okay, so these things you should remember that all dimensions should be in format. Yeah. So this was brief review of drawing command. So I'll not be going into detail of this. So yeah, so what you can do is you can save this file. We'll see here we have for drawing, either we can save in SLDDRW, this is SolidWorks own format, or you can also have DWG format, which is used for saving drawings. Okay, so we'll save with the default format of SolidWorks, that is SLDDRW. Yeah. Okay, so yeah, that's it. This was basics of SolidWorks. Now I will jump to the presentation that I have. Just hold on for a minute. Let me jump to the presentation. Yeah, I hope my presentation is visible. Can someone confirm? Okay, yeah. So I'll continue with the presentation. Yeah, so we have now seen how drawings are there. So I'll just briefly again talk about engineering drawings. So these are basically set of instructions which the manufacturer has to follow. Okay? And you should make sure that these instructions must be clear and concise. So you can see the markings over here, radius, whereas the distance between two concentric circles that you see over here, and you have sectional view. So every dimension is marked properly. So diameters are, you can see the symbol where diameter is mentioned. You see it's a circle and a hash line, whereas if it's the radius, then you see r and certain value. So that's how dimensioning is done, and you should make sure that relationships of dimension each dimension should have certain reference point for its marking. Okay, so that should be make sure while making a drawing. So this was brief review of SolidWorks. So now that we have got idea of creating a 3D object or a 3D model, let's now see how we can convert this 3D model into a real life prototype. Okay, so there are various methods for that, but we'll be specifically now looking at the method 3D printing. Yeah, many of you must have heard it. If you have already used a 3D printer, then it's well and good. If you are not, then you will learn some basic things about 3D printing. So just hold on. I'll turn on my laptop's charging. Okay. Yeah. So let's now start with the second section of the technical session, that is 3D printing. So 3D printing is a modern technique wherein the prototype that you're making, that gets made layer by layer. Okay. So the traditional processes that we have of cutting as well as molding, what happens there is you create the whole object uh, like with one solid form. Okay. Whereas in 3D printing, everything is done layer by layer. And now how it is done, we'll see in the slides further. So different types of manufacturing. First use is formative manufacturing. Then we have subtractive, and we can see additive manufacturing. So example of formative manufacturing is casting process. So many of you must have seen casting. So what you create a mold, then you, let's say, enter some liquid, or let's say you have liquidified cement, then that cement will solidify and you have a cement object. So that's how casting is. So this is a very traditional and old method. Then the other method that we have is subtractive manufacturing. So in subtractive manufacturing, you already have a solid body, and then you use tools on it. With the tools, what you do is you remove the material. So that is called subtractive manufacturing. And examples of subtractive manufacturing is milling, cutting. With these operations, what you do, you remove the material and the desired object is created. So, and as in mathematics we have subtraction and addition, same way we have differentiation over here. In subtractive and manufacturing, you remove material. In additive, you add material. An example of that is 3D printing. Okay. So here you can see in 3D printing, a layer by layer material is added and a solid object is created. So how this layer by layer material is created, that we will see in further slides. Yeah. So why 3D printing is used? So let's now look at economics of manufacturing. So we, like, 3D printing is very trendy term nowadays, but we should also understand logic behind it, like why and when we should use 3D printing. Okay. So 3D printing is mostly used for prototyping, and when the quantity to be manufactured is low, or like a small prototype production. So here we can see economics of different manufacturing methods. So for formative, we see is if the number of parts to be produced are very less, the cost per parts is very high. Okay? But whereas once we go down the graph, that is number of parts increases, you see formative manufacturing becomes pretty economical. The cost per part decreases. It is same with the subtractive manufacturing as well, but not as deep as formative manufacturing. You can see the cost goes on decreasing per part. But compare that to 3D printing, what you say is the cost uh, decreases a bit, but it's almost same, right? So that's the thing about 3D printing. So the cost to create single part as well as creating multi parts is almost same, and so it is only specifically used for low quantity as well as for producing small prototypes. So we will see different types of 3D printing. So for 3D printing, this can be done with 3D printing is mostly done with polymers or plastics, as we call in everyday life. Okay. And then there are various methods. So you can also have metal 3D printing. You can also use sand or ceramics as for 3D printing. So let's now look at different methods of 3D printing. So here we can see the most used method, that is the material extrusion method, wherein this is FFF. So what FFF stands for is filament fabrication. Also FFF, there's another name for it. That name is called fuse deposition modeling. That is also FDM. So this is the traditional 3D printing method. If you have already used 3D printer, you must have seen this, that filament is present, and this filament is melted by a nozzle, and the filament gets onto the surface or the plate that you have, heated plate, and as the nozzle moves from one part to another, then you see that certain geometry is drawn on the plate, and then this in the z-axis the nozzle will go up, and one by one you will see a 3D figure is created. Yes, so that's the basic traditional FDM process or fuse deposition modeling. Then there's another method called wet polymerization. So in wet polymerization, the best example is stereolithography. Okay, so what happens in wet polymerization is there is a liquid resin kind of material, liquid material, and a laser is sent onto this, and this will solidify the liquid at whatever part you want, and a 3D object will be created. Okay? So then you have a powder bed fusion method. In this, the polymer that you have is in powder form, and this powder is solidified and a 3D object is created. So that method, the common method for powder bed fusion is SLS, or it is also known as selective laser sintering. So there are three different methods that we saw. So we can, if you know all these three methods, you should you should use logic to decide which method should be used for what purposes. So let's say you want a cost effective product, then you always go for FDM method or the FFF method. So that way a cost effective thing will be created. But everything has pros and cons. So the con with that is that whenever there are supports, you will have to the removal of the supports is pretty hard in FDM. Whereas if you go to SLA or stereolithography, here the cost is a bit higher compared to FDM, but you will get very precise 3D printed objects. Right? So with stereolithography, the precision is pretty higher compared to FDM. And then if you jump to SLS, here also the precision is higher compared to FDM, but not as precise as stereolithography. But in SLS, what you will see in SLS 3D printed object, there you will always see a texture of powder above it. Okay, because this powder is solidified, and that's how the solid object is made. So that is SLS or selective laser sintering. So there are other methods as well. So you see material jetting. So and then there is binder jetting as well. In material jetting, what happens? Droplets of material are selectively deposited and a 3D object is created. Whereas in binder jetting, a liquid bonding agent is used to bond different materials and create a solid object. Then at the last we have over here is powder bed fusion, but this method is used for metal 3D printing. Okay? And under this we can see the most common is the DMLS. Okay, that is direct metal laser sintering. So as we had seen powder fusion for polymers, same way we have powder based powder bed fusion method also for metal 3D printing, that is the DMLS or direct metal laser sintering. This was brief introduction about different materials and different types of 3D printing processes. So let's now look at different steps in 3D printing. So yeah, so the first step as we can see over here is modeling. So CAD modeling we have already in the first section we saw. So in SolidWorks we have already created 3D CAD model. So what you do is we had saved this in the default file format as SLDPRT. What you can do is you export this file in STL file format. So this STL file format is commonly used file format for 3D objects. Okay, so STL file formats are supported by various slicing softwares that we have. So we'll go through the steps one by one. So CAD modeling now we have learned already. So we know how to create a 3D CAD model. And for step 2, what to do is we convert this CAD model into a STL file format. Then there's an important and different process in 3D printing that is called slicing. So as we know 3D printing is done layer by layer. So the machine has to understand that what it will be printing in each layer. Okay? And that process is called slicing. So as we have, let's say we have fruits in our home, right? So for eating the fruits, what we do is we do slices of it. Let's say we have apple, we'll cut it into slices and eat it. So same way a 3D object is cut into different slices. How it is done we'll see in next slides. We will see visual representation of it as well. And that those slices are then converted into a G code. And G code is the code that the 3D printer understands. So G code is basically like a CNC machine command only. So it tells the 3D printer where it has to move, in what axis it has to move, and how, and that way the print gets made, 3D printed thing. So yeah, so the third step was, so yeah, if, you select these parameters for slicing. So for slicing, you'll see we can select like how many outer layers we have, or how much infill density we want to have. So depending on that, we can toggle the strength of the 3D printed object. Yeah. So once you select the parameters for slicing, you slice the CAD model. Yeah. So then when there are overhangs in the 3D structure, what you do is, for printing, you need to add certain structures, or you add some supports, so that the overhang doesn't fall onto the base plate while printing. So we'll see how it is done. Then after that is done, you obtain the G code. Then this G code is uploaded to the 3D printer. Yeah. So this G code can be transferred to a memory card. If your 3D printer supports memory cards, then you can transfer via the memory card to the 3D printer's memory. Or else, there are nowadays the 3D printers that we have also have internet connectivity. So you can directly upload it to the user interface of the 3D printer, and from there you can print the model. So once you start printing, so printing usually takes time depending on what thing you're printing. So it can take from half hour to multiple days to print a 3D object. So that totally depends on the size of the model that you have. And once the print is done in FDM method, what you have to do is, you have to remove the extra parts, that is the supports or the rafts that are there, so that you get a finished product. So we have now got brief overview of how 3D printing is done. Let's now look at what software we have. So these are certain slicing softwares. So here you can see Ultimaker Cura, then you have Idea Maker or Prusa. So I'll just give you a live demo of Ultimaker Cura. Okay. So as I talked about slicing, here you can see a sliced object. So we have a 3D model of a uh, drone's wing, and here you can see this was sliced, and we have different, we can see the 3D object is converted into different layer by layer structure. So the slicing process itself converts the STL model into the G code that is required for 3D printer. Okay. Yeah. So inside slicing, we have different features, that is the infill, we can adjust the infill density. So as you can see, variation of infill density increases the strength as well. Here you can see a lower infill density, that 15%. Here you will see 50% infill density. That way, this object that will be created will have higher strength compared to the figure that you see in the figure 1. Okay. So this, let's say you want to create a prototype just for testing how it will look, then you can always have an lower infill density, as this will reduce the time of printing, as well as this will be economical also. Okay. Yeah. Then you use higher infill density mostly if you want to use the 3D printed object as for practical purposes. So for supports, I had already mentioned this, that if you have floating objects or cantilever like structure, then you need to add supports. You can see yellow color markings over here below the aerofoil shape. So these yellow markings are actually supports, so that the main part which is to be printed doesn't fall off onto the build plate. And once the whole print is done, in post processing, what you do is you remove those supports out. Yeah. So here you will see another feature called raft. So let's say so the gray area that you see in the background, that is the build plate. So if you're 3D printing on this build plate, and let's say there are some previous material lying on the build plate itself, so what will happen is, the main object that you're printing will have damages at its base, or it will have certain material attached to the base. So to avoid that, what we do is we add a raft. So this raft is basically a layer created below your main object, which is to be 3D printed. So let's say if you want to print the cylinder, this we see over here, below that I will create a raft, and this raft this raft will make sure that the main component that we need is like it's disjoint from the base plate. Yeah. So let's now look at how to do slicing. I will start my slicing software. Just give me a minute. So slicing software that I normally use is Ultimaker Cura. So there are various open source softwares available for slicing. There are also proprietary softwares. These proprietary softwares are of the 3D printers manufacturers. So yeah, Cura is open. So I'll just present my screen. Okay. Can everyone see the screen? Can anyone confirm whether Cura? Okay. Yeah, I see. Yes, in chat. Okay. So you can see. So this is the home screen of Ultimaker Cura. So here you see there are various 3D printers that we have over here in our ERTS lab in IIT Bombay. So right now I have selected the default, that is the Ender 3D printer, which is the small 3D printer that we have. So first inside the software, what you do is you select what printer you have. If you have a new printer, you can add printer. If existing printers, you can manage them as well. You should add whatever printer you have. So slicing varies on what model of printer you have. So you should make sure that whatever slicing or sliced part you are creating or G code you are creating should be for the printer that you have. So I have selected Ender. Then yeah, so there are various materials in FDM that you can use. So common among them is PLA, and then there is also ABS material. So these are all polymers, or in everyday life we call as plastic materials. So PLA is basically polylactic acid, and this is the most commonly used 3D printing material. And there is also a better strength material which is called ABS. So ABS has a pretty weird full form, or you can say the chemical name. So ABS stands for acrylonitrile butadiene styrene. So that's the full form of ABS. And so PLA melts around 190 to somewhere 230. That's the range, 190 degrees Celsius to 230 degrees Celsius. That's the melting temperature. So why I'm mentioning the melting temperature is in 3D printing, the nozzle that we have, that will there is a heating element above that nozzle, and that will first melt the filament, and then the filament will, as the nozzle moves along the bed, the filament will be dropped off onto the build plate and model will be created. So by default PLA model is selected. Then this nozzle hole diameter you have to select. So this totally depends on what printer you have with you. Okay. So on the right hand side again we can see what quality of print you want to select. So here in profile, now you can also create your own custom profile. So there are defaults you can use. So you see super quality, dynamic, standard, different qualities over here. So what this quality is doing is, let's say in standard quality. So basically this is mentioning what height at a time you want to print. So it is 0.2 mm. So let's say if I want a more precise 3D printed object, then it will be, I can select a much smaller size at a time. So, but remember, compared to standard quality, let's say I'm printing dynamic quality, the time to print will always increase. So let's now look at standard quality print. So here by default you see layer height is 0.2 mm. So that is the each layer will be of 0.2 mm. Then you can toggle with the wall thickness. Then there are various toggling parameters. I will just briefly go through them. You can toggle number of walls you want. Also you can have what's the thickness of the top layer and bottom layer. Then you will see infill density. So yeah, as I talked about infill density, you can toggle infill from from almost 10% to 100%, and infill pattern also you can change. Then material you see. So if you are using PLA, we'll use material temperature in range of 190 to 230 degrees Celsius. Let's say if you're using ABS, then it's around 260 degrees Celsius. Then build plate is the base plate. It also needs to be heated when the printer is printing. So that can range from 50 to 70 degrees Celsius. So yeah, other parameters you can keep as it is, that the travel speed, cooling, whatever is needed. Yeah, then we can look at supports. So wherever there is a cantilever part, you need to add supports as well. And there is also parameter called build plate addition. So we had talked about rafts. So there are different modes of build plate addition. You can have skirt, brim, raft. So yeah, so I will show this command practically. So let me first import a STL file here, so that we jump to I had created a file previously. So I'm just importing the STL file. Okay, if you want, I will show the action again. So you can just press on this folder icon and you can jump to the folder that you have where you have stored your STL file, and you select the STL file and click on open. You see the STL file has opened. So with the mouse you can even pan and see how it looks inside the 3D printer's box. Yeah. So this you can see this is a disc cylindrical disc. Now let's say you want to print this, but as you can see, printing this in this way is not practical. Although the printer will be able to print this in this orientation, it's not practical. As you can see, the majority of surface area is on this side. So what we'll do is we'll make sure that the bigger surface area touches the base plate. So what to do, you first select the STL file, then you can see over here, you can change the location of STL file. Let's say on X I say 20, you'll see it will jump to by 20 mm to on the X axis. Let's put it on to default only 0, 0, 0. Then here you can see the rotation parameter. So in rotation, you can select a face that should align to the build plate. So I have selected that mode, and let me now select a face which I want to align to the build plate. So I'll select this. Now you see directly the solid object snap to the base plate. So this is the orientation which I want to print this 3D file in, right? Yeah. So you can see I have now the plane surface is now on the build plate area. Okay. So let's now choose different parameters. As for default, we'll be going with the standard quality print only. As you can see over here, 0.2 mm, and I'll keep all things same. So, and if you want, wherever necessary, you should always take the support generation part. For this, majorly there won't be any supports, but yeah, always you should make sure the supports are ticked so that there are no overhanging parts. Once this is done, you go back. So you can see the parameters that you selected and you press slice. So just hold on for a few seconds, the slicing will be done. Yeah. So here you can see, although it looks such a small thing, but it will take almost 4 hours 22 minutes to print. Also it shows how much material or filament will be used, that is 29 grams or 9.72 meters of filament. So we have now sliced the product. We can also preview how it will look. So here you can see, so for build plate addition I have selected skirt. Skirt is basically an outer line it will create outside the main 3D part to be printed, so that the once the nozzle starts printing the actual 3D part, whatever like obstructions are there, that are already eliminated as it has already drawn the skirt outside. So here you can preview each layer of how it will be printed. Okay. So the red parts you see over here are outer boundary, then you green are inner boundary, and the yellow inside you see is infill basically. Here it is the bottom layer, and as we go above you will see infill as well. And the blue part inside between the circles, these are actually support structures. So there's an overhanging cylindrical part, so it is creating support structures. So this is first layer. On you can see on right hand side I am toggling what layer I am seeing. Okay, so let's see if we go up, you see now there's orange here. So this orange is actually infill material. So initially it was at the bottom layer, it was filling it totally with solid parts. As we go, as we had selected infill of 20%, it will print with that 20% infill only. So we go above. So this is a way to preview how the slicing has been done. Okay. So this was previewing in Z axis. What you can do is you can preview each layer as well. So here on the bottom you see this toggling option. So toggling with the toggling bar, you can see how the nozzle will move for like from start to end in that layer. See, so it will print circles, then infill that way. So you can go to any layer you want and you move this horizontal toggle, you will see how the extruder or nozzle will be printing the part. Yeah. So once you're done with slicing, what to do is you save this file to disk, and you can see this file will be saved as .g code. So G codes are also what 3D printing machine understand, as well as you must have heard or used G codes with CNC machines as well. So G code basically stores instructions for the machine to move in certain directions. Let's say in clockwise, move by this much horizontal distance, this much in y axis, then make a circle like that. These instructions can be stored in G code. So you save the file that you want, and yeah, so once you have saved this file, all you have to do is copy this file into a pen drive or a memory card, go to the 3D printer that you have, and you can just print it on 3D printer. So I'll jump to my slides again. Okay, so that was a brief overview of 3D printing. Let's now look at how a 3D printer looks. So this is a Raise 3D Pro 2 3D printer. So if you have a 3D printer in college, it might be different from this, but I'm just showing you a simple commonly used FDM 3D printer. Okay, so I'll show different components here. So this is the main 3D printer casing. So here in the black area, you can see that is the build plate. On this build, you can see over here as well how it looks inside. This is the build plate. On this, the main prototype will be printed. Yeah, this is the core part of 3D printing. So here you can see a nozzle. This is where the extrusion happens. So this printer you see over here is dual extrusion printer. So at a time it can print two different materials or two different colors of same material. Here you see as it's a heating element. So this temperatures will range from 190 to almost 250 if the printer supports PLA and ABS. So there are cooling elements as well of fan. So this is the extruder part of 3D printer. This is the base plate, and this is the material or the filament. So filament you can see is in the string form. So this is a string it's like a spool of string. Okay, so you can see the filament inside 3D printer as well. So from 3D printer, there's a pipe which goes to the extruder, you will see, and in that the filament will go, and this filament will be melted at the nozzle or extruder part, and the 3D printer will move on the base plate, and first layer will be printed, then extruder will go like whatever layer height you have specified, let's say 0.2, it will move by 0.2 in Z direction, and it will print the second layer. Like that, at the end, a whole 3D object is created. Okay, so that was overview of 3D printer. So yeah, towards the end, let's now summarize whatever we have learned in both the sections. So at the start, what we in the SolidWorks section, we started with sketch. So we made a sketch, then what we use extrude command or whatever features we have to convert it into a 3D object. Okay, so that part you can see the CAD modeling part. Then once we had the CAD part, we can create with multiple CAD parts. You can create assembly. You can also create drawing for manufacturing. But if you want to 3D print, what we did was we saved that part as STL file. Then we imported that STL file into the 3D printing software. We did slicing. and we the sliced G code that we had, we added to it. We can add it to a 3D printer, and we can have a 3D print. And so this is how the process flow works. Sketch, you do CAD, then you go for 3D printing. Okay, yeah. So that's it. Thank you from my side. Yeah. So you can, yeah. Is the host over here? You can unmute the
Yes,
participant.
Saurabh. I would like to share a quiz link. You all can attend the quiz. Do you want to do like a Q&A? I can let everybody unmute themselves then.
Yeah, so the host will be sharing a link wherein you can answer the quiz that we have created. Also, you can ask me questions over here by unmuting, but make sure, so these should be technical questions, and make sure you follow the decorum of the meeting. Yeah, any questions? I see a lot of spamming in chat box. So if you have questions, you don't want to unmute and speak, you can also ask questions in the chat box.
I have shared a quiz link. You all can visit that link and submit your answers within 10 minutes. After that, I'll be switching off the accepting responses. So then you all will not be able to submit after 10 minutes. So exactly by 12:59, let's say 1 o'clock, I'll be shutting the quiz.
So this unmute access has been given to you to ask questions. Please make sure that if you're not asking questions, keep yourself muted. And also you can attempt the quiz that has been shared in the chat.
Today we have a lot of spamming in the chat. This is not acceptable. We have recorded all the people who misbehaved and created nuisance. This is really not okay. So now also, if you have a genuine doubt or you want to have a genuine discussion, then you all can unmute yourselves or else just leave the meeting or attend the quiz.
Sir, I got a doubt. Can I ask?
Yeah.
Yeah, sorry. Actually, I've been like working with SolidWorks for a few years, and I always have faced while doing if you want to changes to a part. Let's say you have a plate of 10 thickness, and let's say the top you got like top face and the bottom face, right? So whenever I want to make changes to the top or bottom, no, I'll be a bit confused. Like whenever I changes to say, let's say I wanted to make changes in the top portion, and in the assembly it ended up in changing in the bottom face. So did you came across anything that can help us to identify on which face we are actually drawing?
Okay. So yeah. So as a shortcut method, what you can do is you can add certain geometry on the part if you are editing. Let's say in assembly, you make certain marking on that part, and you come to the part file, you see the marking, and you can draw there and erase the marking later. This is I won't recommend this method, but you can try this method.
I've been trying that method, but have you come across anything else than that, sir?
Yeah, so if the object is symmetrical, basically you have to maybe you can add a plane onto it. Okay, so you just add a plane. As you know, planes won't affect your 3D model, right? So if you add a plane at certain distance, that will work, and you'll be able to see that plane in the assembly as well, and it won't obstruct your main CAD model.
Because while being in the assembly, if you make some changes, it is not reflecting in the part geometry. So we need to open a part and make changes in the part.
No, in assembly also, if you make changes, you click on edit part and you make changes, it will reflect, but you have to save that. So while saving, it will ask, do you want to save this in the assembly file or you want to save in part file as well? So you should make sure that you save in both the files. That way it will reflect in part as well. You can try this on your own SolidWorks.
Okay, thank you for that. And apart from that, I have one more question.
Yeah.
That's related to 3D printing. When I was using different 3D printers, I've always faced the problem with shrinkages. And
Problem with
shrinkages.
Shrinkages.
Yeah, sometimes you try to print like make a hole of like 5 and it end up with 4.8 or 5.2. Sometimes it will be bigger hole than the expected one. Sometimes it will be lesser the
Yeah,
size.
yeah, that happens.
How do you deal with that, sir?
So one quick fix thing that you can do is basically add an enclosure to your 3D printer. So what happens is there is a lot of temperature variation, right? So you can
Yes,
see
yes.
at the nozzle end, the
Mhm.
temperatures will vary from almost 190 to 230 or whatever temperature you are using.
Yes,
And
yes.
the ambient temperature is some 26, 27 degrees Celsius. Okay.
Okay.
So if you add an enclosure to a 3D printer, this effect is also called warping effect or shrinkages. That there are many errors in 3D printing. So firstly,
Because
what you
earlier I have used another printer which is like
okay,
Fusion. It's like FDM U print or something. That was totally an enclosed one from
yeah,
3D systems.
okay,
But even then we had that problem, so we need
you
to
had
adjust
same
around
issue.
with.
So
Yeah.
another thing you can do is what build plate temperature you had set the value.
Uh, so in this it is around 60 degree, I guess. 60
Okay, okay.
degree. Yeah.
So okay, so 60 is like fine and recommended temperature. So
Mm-hmm.
other than enclosure, like you should make sure that the range of temperature should be like compare. So for filament, it should be 210 to 230.
30. Yeah. Mhm.
Yeah. And for base plate, I guess 60, 70 you can try. So this, I guess you will have to do some trial errors to make confirmation, like specifically for your
Like,
printer
can
if
we
you're asking.
find like, is there any way like we can find some kind of a percentage which we can use in all dimensions?
Acha, acha. So you are saying you will scale up the model and you print and they
No, 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 not like that. Actually.
okay.
Let's say I want to have a hole of 10 and
Okay.
sometimes whether the orientation of printing will affect that size also. Or,
Yes, yes, definitely. Orientation will affect. So,
Mhm.
uh, let's say if you're creating holes that are not up to the base plate that you have, then
Mhm.
obviously you will need supports, right?
Yes, yes.
So you should make sure that the holes are parallel to the base plate. Like it won't be the
Yeah.
case every time, but whenever you want precise dimension, you should make sure that.
Mhm.
Yeah.
Because it
So,
takes a lot of time and sometimes we ended up like
yeah, having bad
printing some
prints or
components
not up
and
to
that is
scale.
not going
Yeah.
inserted at all.
Another
Mm.
okay, send quiz link. So yeah, Gargi, you can send the quiz link again as well. Yeah. So another thing you can do is like
Mhm.
quick fix thing is basically if you the whole printed is 4 mm, you wanted 5 mm, you can
Yes.
use a 5 mm drill.
Mhm.
That's a fix. That's not improving your 3D print, by the way.
Yes, yes, that's because we are in the 3D system one, that printer at least it has got an enclosure, so
Yeah.
it was not showing that differences. But we have something now is from Ender,
Yeah.
and
Ender
it
V3.
always fails in giving the exact dimensions, and
Okay.
we need to make some extra post processing work to
Yeah,
fit
yeah, yeah.
not into the hole and all. So
Yeah, in FDM post processing is a bit hectic, like
okay.
removing the material and to polish as well.
But there is nothing called we can add some shrinkage factor to the Cura software
No,
or
so
something.
like basically you can correct that in dimensions, but I won't recommend that. So this can be like it depends on printer to printer. Okay, so there's no generalized way to do this. Okay,
Yeah.
yeah,
So there is no solution there.
yeah, yeah.
Okay,
Like
sir.
you have to
Thank you.
change the printer, but like yeah.
Okay, sir.
Yeah,
Thank you, sir.
or maybe try changing certain components of the printer, nozzle or something. If you
That
find out the
probably.
problem, specific problem, then you will.
Because even the same thing applies for a 2 crore or 3 crore printer also sometimes, especially the SLS printers,
Mm-hmm.
they are also like that only.
Okay. Yeah.
Okay, sir. Thank you so much for your
Okay. Welcome.
wonderful thing. Thank you.
Yeah. Any other questions?
सर 3D प्रिंटर कौन से कंपनी में यूज होता है?
कंपनी में यूज होता है कि तुम्हें कंपनी का नाम चाहिए?
हाँ, नाम चाहिए सर, मतलब एप्लीकेशन कहाँ अभी शुरू है?
अच्छा, application. Okay. So for application, you can see You're comfortable in Hindi, right? You started in Hindi, so I'll answer in Hindi
Yes.
only. Okay. So अगर तुम कार कंपनीज में वगैरह देखोगे ना, तो ये लोग कोई भी बड़ा कार या कोई भी ऐसा चीज़, ऑटोमोबाइल कंपनी स्पेशली, तो बड़ा चीज़ बनाने के पहले ये एक छोटा प्रोटोटाइप बनाते हैं, 3D CAD मॉडल बना के उसको प्रिंट करते हैं, बहुत लाइक दे विल टेस्ट वेरियस पैरामीटर्स, एंड उसके बाद ही मेन प्रोडक्शन के लिए जाते हैं। तो बेसिक प्रोटोटाइपिंग के लिए लिटरली हर एक स्टार्टअप में, हर एक कोई भी मैन्युफैक्चरिंग और ऐसा मतलब 3D क्रिएट करने में स्टार्टअप हो, वो भी 3D प्रिंटर्स यूज़ करते हैं। फिर ऑटोमोबाइल में भी हर एक डिज़ाइन प्रोसेस के स्टार्ट में 3D प्रिंटिंग से प्रोटोटाइप बनाते हैं, देन दे गो टू द मेन मैन्युफैक्चरिंग। और
Thank
ये
you,
सिर्फ
sir.
ऑटोमोबाइल वाज फर्स्ट एग्जांपल, तुम और इसमें जाओगे, बोइंग वगैरह, एयरलाइन कंपनीज, ये लोग भी यूज़ करते हैं ऐसा आजकल बहुत इंडस्ट्री में। फिर रिसर्च में भी बहुत यूसेज होता है। अभी तुम यहाँ पे IIT बॉम्बे में देखोगे तो हम लोग लिटरली हर रोज कुछ ना कुछ 3D प्रिंट करते रहते हैं। सो फॉर कोई भी बड़ा प्रोजेक्ट कर रहे होते तो उसका एक 3D प्रिंटेड चीज़ पहले टेस्ट करते हैं, देन वी गो फॉर मेटल मैन्युफैक्चरिंग और समथिंग। ओके, या एनी
Thank you,
अदर
sir.
क्वेश्चंस? Okay. Gargi, the quiz is ended, right?
I had said that I'll give them till 1 o'clock, so they have a minute left.
Okay, okay. Yeah. Till the quiz is, till we have time for quiz, you can ask questions. After that, we'll end the session. Yeah, also you can check eYantra's website. So we have different competitions over there. So we have EYRC, EYIC competition. So why during these competitions, you will be learning about these technologies in detail as well. Okay.
I have ended the quiz. If y'all don't have any doubts, y'all can leave the session.
Yeah. So this is last call. If you have any doubts, you can ask.
सर
till
ये
then,
सेशन
yeah.
यूट्यूब पे मिलेगा ना सर?
Yes, yes. You can search eYantra on YouTube. Okay. On that you will see, you will be able to see this session. So you can also see that you can search for directly eYantra technical session.